Hello, so today we have Codeforces round 703 for Div 2, and for the second time in a row, I'm not late for the contest, which is impressive. Yeah, but just joking, you know. It is a Div 2 round, so hopefully we can solve a lot of problems. I've seen scar distribution, it kind of suggests that that F may be out of our reach today, and also 7 problems because of subtasks on C. So it may be a bit complicated on that side, but hopefully it will go well. So let's see how it's going. So we're here. Okay. Okay, so problem A, shift and stacks. Have n stacks of blocks. The I stack contains hi blocks. So its height is the number of blocks in it. Okay. In one move, you can take a block from the I stack and put it to the I plus first. Can you make sequence of heights strictly increasing? Of course I can. So the number of stack does not, oh, okay, I got it. Your zeros are included, so you have to be careful with this part. Let me think. Okay, I will want h0. Okay. The heights can be quite big, actually. Longer. Like my idea is hi. Start with this, if possible, in the end, then I'm always doing this wrong. The correct way is this, of course. Okay. If hi is greater than I, so like if I want to make prefix as small as possible, and as small as possible means 0, 1, 2, 3, 4, etc. So the buffer is like how many blocks can I move further up the road? If each buffer is smaller than I still, so like we can't add anything, so it won't save us. We can just say possible equals false. Right. Otherwise, well, this is actually unnecessary, but yes, I think that by now we maintain like pretty much everything we should in order to. solve the problem. So the answers agree with what I said, which is nice. Do we have any limitations on the heights? No. Okay. I think we're good to go. Okay. 3 pretests. Well, it's not 3, it's technical, like 3,000? 30,000? Yes, it's more or less again. Eastern exhibition makes sense because we live in Eastern Europe and contestator also lives in Eastern Europe. So you and your friends live in N houses. Each house is located on a 2D plane in a point with interior coordinates, thanks goodness. There might be different houses located in the same point, okay? The mayor of the city is asking you for places for the building of the Eastern exhibition. You have to find the number of places, points with interior coordinates, somewhere distance from all the houses to the exhibitions manual. Okay, it's pretty clear, like distance is Manhattan distance. So it decomposes into 2 coordinates quite easily. What is the format? I just need to know. So because it decomposes, like the thing that minimizes is a median. But if you have an even number of points, then median is a segment. Then you're going to just multiply the number of choices for X, number of choices for Y. I'm not fancy finding median in linear time. I'm just going to call sort. But actually, that was not a great decision of them all. I'm just going to break it like that. Because I want to sort them actually separately. Yeah, and it's not the best solution. Of course, you can find median in linear time with nth element, but I'm not into finding it. So actually, all this happens only if n is odd. So like if it's even, wait, if no, it's the other way around. If n is odd, what is it? This is raises some suspicions, no? So I want, like, if n is chosen over, yeah, okay. So like, in fact, I only need to find a median in this element near the median. We're going to just sort because sum of all n's does not exceed 1000 cents. That's interesting. Yeah, of course, because both endpoints also satisfy the condition. 14431, which is pretty reasonable. I have in 6040s here, and this has nothing to do with numbers in products. 1Q, whatever. Very specific colors, I must say. 1Q. Oh, okay. Problem C1 is an interactive problem. Yay. The only difference is the limited number of queries. Cool. So I guess I'm like 40 queries, and here you can 20 queries. Yes. Okay. There is an array A of n different numbers. In one query, you can add the position of the second maximum element in subsegment. Okay. Find the position of the maximum element in no more than 40 queries. Well, okay. Sounds like log. Sounds like two times log and log. Okay. For interactive problems, you got to turn the sync on, or you don't have to. I think you're absolutely fine with this. Okay. We have to read the answer. Oh, it actually returns int. Okay. Right, it returns the index. And then the format of the index is not specified, but at all. Nope. So we're good to go with this handlers. Printing their answer doesn't count as a query. Well, I guess it does not matter either way. Here we have like, okay, log queries. We get the index of second maximum. We get only the index and not the maximum itself. Okay. That's hard. Well, it's not hard to just have to think about it for a minute or two. Because we broke the array into two halves. Ask about the entire array, then ask about the first half. There are two different possibilities. We can get different answers, we can get the same answer. I'm an awful drawer, painter. I don't know how you say it. You can get the same answer. You can get different answers. If it is the same answer, then you're guaranteed that you're in the right half. Numbers are distinct, right? Different, okay. So if you got same, then you're in the right half. If you got different answer, what does it mean? It means that it was actually like third or maybe fourth maximum. Does not you may very well end up with a situation when you have it like here and does not change anything. It's both second here and second here. It can be anywhere. Well, clearly we can solve C1, right? Inclusive or not inclusive? Not inclusive. If not inclusive, then we want interval to be of length at least 2. That's okay. This should be inclusive. Actually, here I want +1, here I want +1. We get answers in both halves. Wait. Right. Okay, yeah, I got it. So what we actually want is we want to compare PA with M. If it's smaller than M, its previous answer, we ask about the same half, where the second maximum lies. If a second maximum from left to middle, from middle to right. Now, if A is equal to PA, then we took the right as the correct half. Right gets to middle, PA gets to A. Else, wait, but no, like if we ask about the same half and get the different result, And we don't know the answer in the second half. Do we? No, wait. This is very questionable observation, I must say. If we asked about the half where the second maximum was, and it's no longer second maximum, and answer is of course in the opposite half, and we don't know like so L equals M. And what does PA have to equal? PA for in R. Yeah, I guess I will just ask like this. So for C1, okay. No, that's not really. No, you can, no, that was a wrong observation. But what remains correct is we can do something like that, I believe. Yeah, so let's actually write down this sample. Yeah, of course. So that's what I was thinking. So they ask us about the index of second maximum on the entire array. The index is 2. I ask from, no, the index was not 2. Their indices are 0, 1 based, right? So the answer is 3. Then ask on, the answer gets 5. Then they ask from 1 to 2. The answer is 2. But you can't ask about L equals R. And also L is the index of, is it the index of maximum? Or, oh, that's complicated. I want there to be how many elements I actually want there to be? Do I want like 2? No. I want the half that I'm about to ask to contain at least 2 elements. If I have 3 elements, I may still run into issues. Suppose that I have at least 4 elements. Well, I have at least 4 elements, each half is going to contain at least 2. Okay, but now L is not necessarily the correct answer. I got 4 elements. No, I got at most 3 elements. And PA is the index of second maximum. I can't have 1 element. I can have 2 elements if I have 2 elements. That's annoying. I think there's like a simple workaround here, but I don't see it. Wait, what? Oh, okay. So if it's here, uh, and this is not the kind of problem you want to solve. But PA actually contains maximum on. Okay, so what did I ask from? I ignore the last element. Okay, if A equals PA, and I'm about to answer L. No. Yes. How bad a problem can I ever get? Like this is the worst. This is the worst. Second maximum is this, and then do you really expect me to test all the branches of this solution? You're crazy awkward. No, really. Like this, if, okay, 5. Second max has index 3. Max from 3 to 5 is 5. Max from 1 to 2 is second max has index 2. Now this is correct. I don't trust it. Let me create a random array. I have an array of 9 elements. The index of second maximum is 5. Index of second maximum from 5 to 9 is still 5. Index of second maximum from 5 to 6 is 6. From 7 to 9, it's 7. From 8 to 9, it is 8. Answer is 9, right? Oh, okay. So the only thing that changed is the white space. Yeah. I may be very wrong, but I think I actually did everything. Okay, but it's like 40 queries because I ask about every half all the time. People are too smart. Yeah, look at this. Look at this. I'm just insane. Maybe there's like my problem so far is that we can often, when the half changes, I have to ask another time. Yeah, so at the moment I need to reduce this part. Well, like this part is must one extra query. I don't care about that. But here, so we are left with 19, and 19 is log, and well, maybe log plus 3, but not 2 times log. And here we make 2 times log because of this and this. Problem is that if I know the answer for the entire array, and I slice it in 2 and I ask again, the answer is the same, then I'm clearly in the right half. But if the answer is different, then I don't know what it means. No, I actually know that I have to go to the other half, right? But there I don't know what is the second max of that half. So I have to ask it again. So yeah, I like use 2 queries to get the answer. Maybe I should exclude it on purpose, like ask about the different half. And I'm clearly getting the wrong answer. And I have no idea where the max is, like the real max. Is it really that easy? Is it really that easy? Well, yeah, like 3/4 of people. Okay, 2/3 of people who solved C1 solved C2 also. I'm going to divide in 2 in 1 query. Now where the second max is. No, I have a stupid optimization in mind, but it does not help asymptotically, not at all. And the problem is that second best is not enough to locate the first max unless you got some information from the queries that you made previously. So you want this information that you queried previously to tell you something. And does this trick really help? Suppose I asked somewhere and then instead of dividing like, no, it does not help. It's not help. Not at all. I don't know, people. We need to think about something else for a minute or two because I don't know what it is about. Problem D max median. We given an array A of length n. We want to find a subarray with length at least k with the largest median. Okay. Oh, really? Is it? Okay. That's smart, I must say. Wait, does it really make sense to take longer windows? It may actually. Have like 100. Yeah, if you have 100, 100, 100, 100, and you want length 3, and you actually want to take a longer window. Great. Integers are up to n, which is interesting. Can you use it to trick the system somehow? I'm thinking of a sliding window, but it's not clear how to actually make it work. Because it's just not clear. So this started off a bit more valuable than both C1 and C2 interest. Well, at least we have like unique problems. Wait, my example is incorrect. My example is incorrect. Of when we want a like longer segment. Than we were asked for. Is it? Like if it's a sliding window, then I can do it with just 3, right? Logarithmic wire for median, insertion, deletion, multi-vacuum offset, yeah, 3 of PRs. But is it actually optimal to have lengths equal to K? Yes, okay, so it's just a longer. It's just a longer one. So it's not always optimal to take the shortest window possible. Sometimes you want like to extend it. If you have like high segment, low segment, high segment, and you want to take both of this. Maybe we want to another binary search, like really over the answer. So we just want to check whether we can get some given value of median. How to do it? Suppose we have another sliding window. That's not clear. No, this is complicated. I'm going to take a short break and come back to the problems. Okay, I'm going to try to attempt D with binary search over the answer. But to be honest, it's a bit too hard. I don't know. I was not ready for this maybe. But it appears to me that it's a bit too hard. So low is not never possible. High is no, other way around. Low is always possible. High is never possible. So I want to print low. Both are small, so I can afford taking it like that. If me is possible, Batchman. Low gets me. High gets me. What I want here is the following. Big E is true, big I is true if and only if AI is at least what we are going to test for median. Now the idea is the following. We actually want a difference. This happens and big is equal to say 1. Let's say -1, right? You know who is greater or equal to median that we're trying to get, and who is smaller than equal. Now we want two things. We want to select a subsegment in our array of negative and positive ones, which has length at least k and positive sum. It should be easier. Should be easier. Or maybe we'll need prefix sums actually, if you think about it. Because like subsegment sum is always about prefix sums. Let's start like that, and now we have prefix sums. Does not help us directly. Maybe we'll find it useful. What if we maintain now a queue, a monoqueue, actually a monostack? Okay. if big prefix at I is great. What? I'm only interested in negative values. If it's negative, this is greater than size of this. Say this is -1. Yeah, okay, greater than equal. And I want to push back I. So by now I know what is like the smallest index to get some sum. And I want the smallest index to get some sum for the following purpose. Like if I look at the current sum, I'm interested, if I look at the current prefix sum, and I'm interested in, first, I want previous sum. Like I'm looking at R, okay, at the right boundary. I want left sum to be smaller, and I want it to be as small as possible, L, so that I can get to K. Okay. Else, it's not the smallest so far, and I can select smaller one by querying what is L. So here we actually have R. Clarify it. At big prefix R -1. If R minus L is at least K, then I can return true. Now this has to be simplified. Clearly you don't need this, so you can prefix sum 0 left This is the first part. Now the second part. This is not in the test case. Yeah, this is incorrect. We can't have median of 3. Well, actually, like if you think about it, like this is clearly incorrect. Right. Why? Let's make it in a different way. We have map left. Now left is going to work in a different way. So left at PS equals, no, not like that. If left count prefix sum is 0, left PS should get right. This is incorrect. This returns 0, which is clearly incorrect. It is the following, like if there is no such key, left is the smallest thing that you can take to get some prefix sum, and want to get a smaller prefix sum. So clearly we are always getting high equals middle because we are always getting impossible because we are getting there. So this is wrong. Now why this is wrong is not actually clear. Now let me do it like this. Or maybe because we are happy with yeah. We are happy not only with like sum minus 1, we are happy with every sum that is smaller. Now for negatives, okay. How about that? Now this is still incorrect. This may be correct. Maybe. But I'm not going to trust it. So I have a test in mind. It goes like this. Want window of length 5. Just to clarify, you should get 100 because you can take the entire window, which is incorrect. For some bizarre reason we... All right, okay, that actually makes sense. Integers have to be... Okay, suppose I do this. Should get 7 because we can't take the entire thing. I don't know. It's likely that we are going to catch anything strange on random tests. Yeah, we can have 8 if we take just here, this 3. Should have kind of did it like this and then like this. I think the answer is 6 now. Yeah, well, I think it's reasonable. This is the length. If you have negative values, then you just put them like that. And leave. Where's the yeah, there's no such values and you can't have perfect spot. Okay, that was really hard. I doubt it, but we got to try. Okay. It's kind of slow because I have log squared for the map. But probably I can do an ordered map here, but I kind of don't want so. Right. Okay. A lot of people solved C2 and I just don't understand. I just don't get it. I don't know. Like I thought about the idea, like what if we divide not 1-to-1, but let's say 2-to-1? And I guess that the optimal ratio is Golden ratio, and then it's just not enough. It gives you like 24 or 25 squares in the worst case. And worst case is like easily constructible. It's not like you can get away with random algorithm because it's not random. That is a big problem here. I just don't get it. Like everyone solved them like the same way, right? Yeah, if they really got like 2-to-1 or a 3-to-2 ratio, 3-to-1 or 3-to-2, no, 2-to-1 or 3-to-2 ratio to work, I'll do my best to hack them, but I can't do it now. And it's kind of unfortunate, you know. To get some points, it just won't work this way. Maybe we can try our luck with problem E. It does not look impressively possible. Maybe it's not that bad as C2, I don't know. Right hand set is an ambidirectional rods in the contrary, so it's a graph problem. The rods in the contrary form an undirected weighted graph. Okay. Not guaranteed to be connected. Okay. Some parameter weight. Cool. Unless you're two rods at a time, so from A to B to C, and you have to pay. I hope it's not another shortest path problem. Because if so, I'm not really sure what we should do. Find if it's possible to travel from 1 to every other city T, and what's the minimal amount of money you need to get from 1 to T. It's not possible, output -1, okay. Weights are not high. This is like very, 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 very tricky. Obviously, we can't take the closure of the graph, so we have to think. And thinking about shortest path problems is not my strength. Like, I don't know the like default algorithms, but then I don't know anything. And this is just how it happens. Uh, Yeah, just D. This is the kind of style that we will need regardless of what shortest path is being asked. So we can do it just straight away. Weights are really small. We have to use it somehow. And I don't understand how. Unbelievable. Unbelievable. 39 minutes. These people are mad, I must tell. And at the same time, one of my friends spent like 1 hour on C, but got it completely. And then got D pretty quickly. Yeah, I should have full switched to D and solved it faster. I mean, we are still not guaranteed that this will pass, or like this should pass, because extra luck is not that major problem. But still. Kind of for shortest passes that we can we use? Not really. It's not even clear. Don't necessarily can enter our city. And we can't take the closure. Then for some reason weights are at most 50. This, okay, like this payment, square of sum, I think it's really constructed just because you don't want to get it to be in any way separable. Because you can't say that it's sum of some function of WAB and WBC. Well, okay. Like what I am currently thinking is that we can have a multigraph in the manner that we duplicate vertices with the following way. So like distance to vertex can be either 0, which means that it is the second. We reached it by the second route, so it's a full step. Or it can be a half step, and then we are interested in what is actually W, or which we reached it. Yeah. But then the problem is that no, there are no problems. I mean, the only problem we see here is that we get 5 million vertices, and it may be a bit problematic to run Dijkstra. But I think it's possible. So it's actually 51. So again, have we of path H or 0 if a full step. D0 at 0 is 0. Then we have our Dijkstra shortest path. Well, at least edges do not duplicate, right? And that's a good thing. That's a good thing. Well, that's actually, I'm pretty sure I have. Where is it? Where is it? Shortest path. Dijkstra. Dijkstra heap parents. Parents? What? Dijkstra array. Dijkstra array. No, Dijkstra array is the slower version. It's in a faster. No, it's for Bell. Okay. This is completely unnecessary. So the true index is I plus n times v, or full step. One times n. No, the n is duplicated as well. What the? Okay, okay. Yeah, this vertex duplication technique is like really the only thing that can happen in shortest path problems. The only difference that I don't want to. And it takes care of everything for me, I guess. No, of course, return distance. Okay, so auto distance equals Dijkstra heap where 0. To be honest, like 5 million vertices, 10 million edges, So that's pretty tricky, the extra. But I hope that with priority queue and everything as an integer, also weights in distances never get too big. So we don't know how to play this. And the thing that happens here is this is actually VAB. In this case, we have like our weight is VBC actually, right? So VBC equals 3, B equals 3. Uh, graph should have copied this definition. So this graph. This is really a graph, so that's good. So, how much time do we have left? Enough. Have more than enough. So because previous was 3ab times n less back ue, can result again this. What was the weight? Like we already paid something. Let's say we paid the square of VAB. So now we can take quite simple, right? That's a massive way to separate them. Now we want to think like, what if actually this is the first edge? Then from here, where? Here, play this, and here we play this. I have first edge and a pair and second edge. Not exactly, not exactly. Yeah, now it's better. Well, this is actually E1. E2. Pretty sure we don't have to care about interior overflow. What is the max actually? Oh, we do have to care because we can have 100 sum of weights, then squared, which then yes, we do have to care about overflow, man. Oh, this is convenient actually. Graph, undefined identifier, because it's G. Distance count before initialization. What line is it? 28. Or maybe graph was undefined. And that's why it couldn't run it. Now these are all correct. You just have to check the 0, -1. The -1 is correct. It may not be fast now, but I don't really know how to speed this up. Let's see if this works. Like time limit is increased, but it may not be enough. Do I have to? Well, that's unfortunate. Like really, we have a problem. Values are up to 10 to the fifth, okay? And so the length of the longest path in number of edges can be 10 to the fifth. And then 50 plus 50, 100 to the power of 2, 10k, 10 to the 4th, wait, 10 to the 4th times 10 to the 5th. What am I talking about? Do I really can make everything int? I somehow thought that there is another 0. It's going to save us memory 2 times, right? And I can't save much more. I really don't know how to save much more. Run Gans for 100, you know. On the edge, boss in memory and time. So like I would expect it to get hacked or fail system tests. Honestly, but maybe, just maybe, Anton Ryub decided that like, well, that's previous time we had weak pretest, so let's have strong pretest this time. I doubt it, but yeah, something like that is possible. Resubmission was completely unnecessary, but at least we are getting back where we should be. I have no idea. Maybe I just should submit this version with like smaller part gets 1 minus phi small, and second part gets phi small. But I just don't trust. Yeah, big bug. Cool. Solved F. Amazing. Well, this actually means that we are on the right track. Like if Damara got +2 on memory and time, it means that he was trying to squeeze in long integers. It didn't work, and then he decided to go with this. But that's pretty bad because, like if I understand everything correctly, it basically means that you have to write in C++ or Java, but not in Python, for example. Can we have Python? Rust. Well, Rust is pretty performant, I must say. You see where this is going, right? And by the way, why are you not my friends? You should be. Kotlin. Well, Kotlin is basically Java. That's Rust. So Anton Group skills Python. Cool. I support his decision. No, but frankly speaking, that's a bit strange. Like, yeah, we still have 25 minutes. What should we do with it? With them? I think we should try to solve C2 because it just. I mean, the idea of dividing nodes equally is cool, but according to my calculation, it does not work. If it ends up working, then I'm pretty bad at math, I must say. Or pre-tests are pretty bad. Maybe I just should think for a bit longer. I will pause the recording for now because I don't really talk when I'm syncing. You will see no activity on the screen whatsoever. So a short pause. Yeah, guys, unfortunately, like F is clearly out of reach because some LGMs spent 1 hour trying to get it, and some IGMs as well. So, and I don't understand what C2 is all about, so I'm afraid that's it for us for today. I will try to figure out C2 after the contest and upsell it, but I don't really understand what it's all about. If it ends up being that thing about unequal division, and I can't hack it, well, maybe then I should work on my math skills because according to my calculations, like to get 20 queries, you need in 2 steps decrease number of options by a factor of square root of 10. And the best you can get with golden ratio is phi plus 1, which is 2.6. And square root of 10 is approximately 3.3. That's nowhere near enough. So maybe you have to be like very clear about how you divide. But I'm afraid that I'm not all that clear. Not all that clever. Or maybe I'll just ask Andre about his solution. And to be honest, I'm not sure that this or this will pass the system tests, because it's very easy to get all by 1 errors in a binary search, as was seen in the previous one coordinated by Anton. He doesn't care a lot about it if somebody fails system tests. So this is vulnerable and this is clearly vulnerable because we are very tight in both memory and time. And keep in mind that priority queue is generally faster than send, so here I'm doing the best I can. I don't really think that you can get away without pairs. Also, it should be optimized where pairs basically two integers lying next to each other. And also I break whenever I see that something is unreachable. So I don't really know any way to significantly improve performance of this solution. I guess we'll have to leave it as is in hope for the best. So yeah, that was it for today. I hope you got the solutions for D and E. because these are kind of more interesting problems than the first three. Maybe if I figure out C2, I will comment down below, like what was the main idea. So thanks for watching and bye bye for today.